Hello and welcome to Module 6, Python for Data Science, part of your Python Foundations course. So until now, you've mastered the building blocks of programming, variables, loops, functions, and more. Now, it's time to put that knowledge into action in a way that's directly used in data science, machine learning, and AI applications. So in this module, we'll take your first practical steps into the world of data science using Python. This means you'll learn how to work with real-world datasets, do number crunching efficiently, analyze and understand data patterns. To do that, we'll be introducing you to two most powerful Python libraries used by data professionals across the world. First is NumPy, the numerical Python. So the numerical Python, the NumPy, is a super fast libraries for working with arrays. It is used for mathematical operations, statistics, and linear algebra. Number 3, this is essential for machine learning, simulations, and scientific computing. And second important library is Pandas. So your go-to tool for working with tabular data is Pandas when you have in rows and columns. So Pandas helps in reading, cleaning, and analyzing real data sets like CSV files. The Pandas makes it super easy to explore trends, group data, and draw insights. Don't worry, we'll just keep it beginner friendly. You don't need a math or a data background to start. So this module is hands-on, interactive, and focused on real-world examples to build your confidence step by step. By the end of this module, you'll be able to handle data in arrays and tables, clean and prepare data for analysis, use Python like a true data scientist. Now, let's begin this exciting journey into data science with Python. Let's dive into NumPy, your first data science toolkit. So what is NumPy? NumPy stands for numerical Python. It's used for efficient numerical computing such as arrays, matrix operations, statistical calculations, etc. So how do we create a NumPy array? I'm going to use this NumPy array first by importing the library. Since we have used Anaconda, default libraries are installed like NumPy and Pandas. So how will I import this library? Import NumPy as NP. Now let's understand the one-dimensional array. What is a one-dimensional array? Array 1 is equal to np dot array 1, 2, 3 and 4. Now let's print array 1, and two-dimensional array is array 2 is equal to numpy dot array 1, 2, 3, 4. Now let's print array 2 dimension. It's what mistake did I do? np dot array 1, 2, 3 and 4. Okay, I need to pass this entire thing inside and square bracket. This is print, right? So print, print. Right, so you can see numpy dot array. Right, so an np dot array, if it's in 2-dimensional, so within a square bracket, I need to pass this 2 dimensions. Right, in separate square brackets. np dot array creates a numpy array. So the input for this is a Python list. So 1, 2, 3, 4 is a Python list. The input is a Python list. The output is a one-dimensional array. 1, 2, 3, 4 is a one-dimensional array. Right? Now, if at all I want to check what is this type. Now let's check print type array 1. This is an NumPy n-dimensional array. Right? So what is the shape of this? Now let's print array 1 dot shape, print array 2 dot shape. Right, so the shape here is 4 comma and this is 2 comma. Right, so there are 4 values within this one dimension, and in the second we have 2 comma 2. Right, so we can see that there is 2 comma 2. And how can I slice and index it? Like how we have sliced and indexed this the lists and tuples. Now we can use that similar format, print array 1 of 0. I can extract this first element out of this NumPy array, right? So Now you can ask me a question, what happens if it is in 2 dimension? Print array 2, 1 and 1. So the first element, so 0, 1, 0, 1, right? So I can give it as 0 and 0 to extract this element. It's the first element from this 2-dimensional array. Right? So there's the indexing and slicing. There's the indexing and slicing that we can do. Now, what are some NumPy math operations that we can perform? NumPy math operations that can be performed. Let's just say, for example, numpy.array 10, 20, 30. I'll call this in an object ARR. Now I'll print array plus 5. Now let's print array star 5. Now let's print array divide by 10. Right, so I'm going to take each and every object, every value that's present in this NumPy array. Just by calling that variable name, I was able to add 5 to each and every element that's present in this NumPy array, which was not possible directly in the list in tuples. So array into 5, right? Now I can use this aggregate functions right away. NP dot sum of array, right? So NP dot mean of array, right? 60 and 20, right? So all these things can be performed right away. Now let's also take an example of how to add 2 array lists. So for example, first let's create 2 arrays. A is equal to np dot array and let's give 10, 20 and 30, and B is equal to np dot array. Let's give it as 1, 2 and 3. Okay, I'll have to pass it in a list, right? So now let's add the arrays. C is equal to A plus B, right? So C is equal to A plus B, and now let's print C. See, the addition is so easy. We were able to add the index values of one array, NumPy array, to the index value of another array. So this is called as an vectorized operation. This is called as a vectorized operation. It's fast, memory efficient, and avoids the need for for loops. In the classical list scenario, I'll have to write a for loop to add one index value to another, right? So this was so hectic. Say for example, I'll have to write the result. So I'll say it as without NumPy. So how difficult it is. I'll create an empty list called as a result here for I in range length of A. Okay. Now what will I do here is result dot append A of I plus B of I, right? Now let's see this. Now let's print the result, right? So 10, 11, 12 and 13, right? So this was a classical way of doing it, right? So this was a classical way of adding 2 different lists. Right? So for example, I'll give A is equal to 1, 2, 3, B is equal to 4, 5 and 6, right? Now let's add the result. What happened if I had to give A plus B? This will append one list is concatenated to another list. Unlike the NumPy array, it did not do a vectorized operation. Rather, these 2 lists were concatenated when this is a list data type, unlike an NumPy array, right? So this is very important, and you can see how it has performed. Before we move to pandas, so I shall give you some practice ideas. What are some practice ideas that I can give you, right? So we can make, you can create an 1D, 2D array. I'll give this as exercises. Now, right? So you can start creating an 1D and 2D array, slice a 2D array to get in submatrix, perform element-wise addition multiplication, NP range, NP linspace to generate a number ranges, calculate the average mark of 5 students using this NumPy array, right? So this is some practice ideas or some exercises that you can explore on, right? Now, what did we learn? So far, we have learned how to import a library, and we have imported a NumPy library, and we have created a NumPy an array, and we have sliced a NumPy array, and we have also performed some mathematical operations using NumPy, right? So in forthcoming session, we'll also extend this by reshaping access-based operations, okay? And we'll also jump into pandas, and we'll also explore the pandas basics, what's in series, what's in data frame, and how to handle in CSV. Thank you.